Hi everyone, we're going to use the given complex zero of -5 to find the remaining zeros of each function, and we're also going to use synthetic division. If one zero is -5i, then we also have 5i. Okay, so I got it set up, and let's get started. It's a lot easier actually than long division, if you can keep this straight. So bring down the 1, and multiply 1 times -5i, which is -5i. You add these, and you get 3 minus 5i. Now, the tricky part starts now. So what I do is I just go to the side and multiply -5i times 3 minus 5i. So when you do that, you get -15i plus 25i squared. Now, I squared equals -1. So I can change that to a -1 by changing this to a negative. So that's when I'm going to write -25 minus 15i. Now, when you add these two, you're just going to get -15i. So this is the part you got to be a little bit careful with. Then the rest is pretty easy. Multiply -5i times -15i, and that's going to give you 75i squared. I squared is -1, so just make that negative, and that gives you 0. Okay, now to finish off, we're going to have to use our other 0, which we know to be is 5i, and the rest is pretty simple. Bring down the 1, multiply, you get 5i, add, you get 3, multiply, you get 15i, and that gives you 0. Therefore, if you wrote this out, this one would be x plus 5i. Whoops, all right. This one would be x minus 5i. And then this part right here is just x minus 3, or x plus 3. So your zeros are -5i, which they gave you, and the ones you had to find would be 5i and -3. And that's it. Thank you. Have a nice day. Bye-bye.